audible? Area like artificial intelligence and machine learning for medical image analysis using the Python programming. So it is a very famous topic nowadays, hot topic nowadays. And under this hot topic, there is one category that is called the generative adversarial network. Why we are learning this topic? The thing is, we have to implement the machine learning and the deep learning models. Also, we have to protect our models from such attacks, such as appending the noise, as well as changing the layers inside my deep neural network, such that misclassification of the image or misclassification of the patient's data or medical images can't be taken out, right? There is a pointer here. So these are the contents I have to cover in the session. First one, we will take the introduction of the GAN, then detail about the GAN, then we will discuss about the component about the GAN, then what are the specific application areas related to that GANs that we will discuss. Type of GANs, there are different category of the GANs according to your application area. Then detailed architecture of GANs, because in terms of the implementation understanding, we have to first learn about the architecture components. And the last one is hands-on. Next. So before going to the theory, first you check this image. There are two images, right? So I want to ask that which one is the real and which one is the fake. So before going to this answer, just tell me which one is beautiful. Right? This one is beautiful, obviously. Now second, coming to the first question, which one is real? How can you say the first one is real? Because it's not beautiful as compared to second one. You can see the first one is noisy and the second one is not noisy as compared to first one. Yes, very difficult to recognize. So this is the answer that the first one is right. First one is real one and the second one is fake one. It is not real. It is generated by your GANs, the today's topic. Okay. Go to the next slide. Yes. You can see the categorization. The circle which is depicted by the red one, these are the fake ones. And the borders which are represented by the green ones, these are the real ones. Now you can see the red ones is so much clear, as well as you can see the so much uh, pursuing to the user's point of view as compared to the real ones. So we can say in the generation AI can take over our human mind, right? We can focus more on generating these deep images, fake images. How many you have activated in social media? All of us? All of us? There is a one controversy is going on, Rashmika and Alia Bhatt, right? So this is another example of deep fake, right? Next. So let's go to the theory. Application हम देख चुके हैं, theory देखते हैं. So generative adversarial network is developed by 2014 by one of the researcher that is called Goodfellow and his teammates. Okay. So actually, what is the reason to generate this generative adversarial network? The common machine learning and the deep learning, things, what having? There is no process and there is no any mechanism to identify and you classify the images which having some noises. Like you have some DL model, you are putting one image to identify which one is the dog and which one is the cat. Your deep learning model is able to classify properly that okay, this one is the dog and this one is the cat. But you are fooling to the deep networks now. You are appending some amount of noise over the image and again putting the input as a deep neural network. What your neural network will provide the output? that okay, this one is the dog and this one is the cat. Again you add some another noise, and at that noise these are only conversion, like dog will become cat and cat will become dog. Now you are able to fool your deep neural network model, right? So this is the basic implementation of the generative irreversible network, that we have to fool the neural network such that it can misclassify the data. Okay? As you can see in our previous slide, that we can't distinguish about the real one and the fake one. Just go to the previous one. If we remove this labeling like red and green, so it is very difficult to identify that which one is the real and this which one is the fake, right? Right? Go to the next slide. GAN is basically an approach that is called the generative modeling, that generates a new set of data based on training data that look like the training data. So this statement is somehow confusing, but I'll tell you in a very simple manner. Generative modeling. Generative modeling means there is a model who generates some sample images to you, and these are fake images. Okay, that generates a new set of data, means sample images based on training data. What are the training data? Training data is nothing but real data. So now we have two components. The first one is called sample data, and the another one is real data. Your sample data is generated by the generator, and your real data is used by the discriminator. So what is discriminator? I will tell you. So this sample data is generated by the generator, that is called the generative modeling. We have to model our deep neural network in such a way that it can generate the sample data that is nothing but fake data. That look like a training data. That look like a training data. So suppose I have an image of cat. That is real. Now the role of generative modeling to generate a data in such a way that it can look like a cat, right? Now another question related to this point. You tell me that your generative modeling is supervised learning or unsupervised learning? Unsupervised. What about your discriminator? Okay, so I will again ask you the same question after few slides. To look like a training data. So what are the parameters I have to feed over there such that this fake data will be created? As you told me that it is an unsupervised learning approach. Means there is no previous data. If there is no previous data, then how can it generate this fake data which is somehow similar to the real data? Now GANs have two main blocks, generative and discriminative, which compute with each other and are able to capture, copy and analyze. Capture, copy and analyze means these two components are learning with each other. These two components are basically competitors to each other. What the competitors will do? They have to achieve some point, right? And also they have to learn something from each other. Then there is a competition. So these two models are called generative and discriminative. So I think that generative things is clear to you. Now let's talk about the discriminative modeling. So discriminative modeling is nothing but your neural network that you already know. Okay, real neural network in which some real data is fed for the training and testing is done by 80 and 20%. But we have to make some correlation between the generative and discriminative. Why we are doing this? That we will consider in our next slide. So to understand the term GAN, let's break into three parts. Generative adversarial network. So as I already told you, generative. So you can see it is a unsupervised learning approach. We have to put some noise over there at initial level. Okay? Some random noise. In the image processing, how can you fit the noise? There are some noising tools like Gaussian noise, right? There are so many noise methods over there. So these noise can be used over there. For this noise, you can generate any random data which is not similar to your real data. Obviously, for the first time, it is only the noise. But when the model is getting trained and learning and adapting by itself, so what is the images? This is nothing but the pixel itself, right? So suppose at the initial, the pixel is 0, 0, 255, 65 like this one. Now it is compared with this one 0, 0, 255, 65, 85, 100, something, something. Now they have to compare with this, and according to this one, they have to again iterate the process by defining the weight. So generator has to help, generator has to ask for help to train itself. Means there should be link between the discriminator and the generator that we will see in the diagram. And the network, what are the networks? Network is nothing but this is another neural network and this is another neural network. There are two neural networks running in the generative adversarial network. And we have to link between these two neural networks. Achha. So the generator network takes random input, typically a noise, generates samples such as image, text, and audio. Okay. So as I told you that my example is again stucking with the images. So it is not the case that itself each time we are taking about the images. You can take any video also. You can take any audio, music files or any text files in order to copy and provide some fake images or fake, you can say clone voices, clone videos, right? Resemble the training data real. Okay. So it will not touch the training data. Training data is nothing but the real data, but it will try to copy. That's why the previous slide is saying copy and analyze. Tries to copy the training data. Now there is one restriction over there. The restriction is this generator will always produce an image pertaining to a particular field. Suppose I have a food company, right? And in the banner, like this banner is animated banner and I want to produce images of the food day by day. And these food images have to be changed. Like for one dish, like sambar bada. Okay, or you can say the masala dosa. Masala dosa can be represented in different formats like palak dosa, masala dosa, masoor, whatever the thing is, anna masala dosa, right? And itself the palak dosa is again represented in a different format, like in the cutting in a square, in a rectangle shape, right? So if I'm doing the manual process, it will take a lot of time. So I have asked to one AI company that I want some images generated by you and these images have to be changed day by day. Like the palak dosa have to be represent one day in rectangle, second day it should be triangle and the third day should be square like this one. Okay. So my field of area will going to fix. Like this way, if I'm taking care about the cat and dog, then my generative modeling should able to generate the images only for the cat or only for the dog. It should not produce the car image. So field should be specified over there. That's the main thing we have to remember. Goal is to produce samples that are indistinguishable from the real data. Means what are the aim of the generative network? Generative network aim is it has to produce some fake data in such a way that my discriminator will able to confuse that which one is the real and which one is the fake. Okay, like we confused in our first slide that which one is the fake and which one is the real. Same thing we have to implement over at the coding part. My discriminator, what is the discriminator? Discriminate, classify, like inspector. Okay, inspector can see and say, okay, this one is the thief and this one is right. So discriminator is able to identify that which one is the real and which one is the fake. Next slide. So let's talk about the discriminator. Pointer है आपके पास, slide दे दीजिए. Tries to distinguish between the real and generated samples trained with real samples only. As I told you, real data से ही हम sampling करेंगे. Also trained with generated samples from the generator. Why the third point is coming out? We are training our discriminator with the real data such that it can identify that which one is the real and which one is the fake. It is okay. But the third point says that we have to train our discriminator with the fake images generated by the generator. For making the correlation. For the first time, it can able to identify that which one is the fake and which one is the real. That is okay. But after that, the aim of generator is to fool discriminator such that discriminator can classify the fake data as real. So we have to take some sample data, some amount of sample data and train inside the discriminator for the initial process. Correctly classify real data as real and generated data as fake. So it is just like the simple neural network, that is nothing but the only third point addition is there that we have to train our neural network with some label fake. So there are two labels in our discriminator, real and fake. So it is a classification problem, right? Real and fake is a classification problem, right? Now how the training process? Adversarial game between the generator and the discriminator. As I told you, my generator and the discriminator are nothing but the competitors. So there is a game is going on between the generator and the discriminator. The game is saying that generator can generate the sample fake images and this sample fake images is going to the discriminator. If the discriminator is identified as a fake, obviously for the first time it will categorize as a fake. When they fake, then some loss penalty will be calculated by some entropy function and this feedback is going towards the generator. This is nothing but the feedback. Now this feedback is very important because this feedback the generator has to adapt itself with the new weight, right? Just we are providing the feedback to the students, right, in terms of marks such that they can improve. The same thing happen over there. This is the student and this is the teacher. Now the student is producing some samples over there. Teacher is checking and according to their evaluation, it is providing some feedback to improve its performance. So such that we can say this discriminator is providing help to the discriminator to generate more fake pertaining to real images. The adversarial training pushes both the networks to improve over time. Now when this stops? This will stop at a point that is called the convergence point in which whatever the sample data generated by the generator is categorized as a real one by the discriminator. such that we can say generator successfully make discriminator food and the job is succeed. Now these are the domains. The first one is image synthesis. So image synthesis is what? Some manipulation we have to do inside my image. It is not the transformation. It is some manipulation like background changing. Webex, Zoom, there is some tools now over there in which we can change our background. Okay? Now text generation, some styles we can change. Video generation, there is some video, Alia Bhatt and Rashmika controversy, video generation. Generating realistic images, as I told you in my previous slides, there are some celebrity images which are pertaining to real, but these are fake images. Creating deep fakes. So deep fakes is a model in which transformation is done. Like inside my face, I can put to her face, and it is just as real. It is not the fake type. Enhancing low resolution images. So it is a very good area. Enhancing low resolution images. We can use the GAN network inside the satellite images. Satellite images are very blurred because they are capturing from a very long distance. So we can use the genetic adversarial network to increase its resolution. Like we can say in my second slide, the second one, like right hand side, the actress is high resolution image without noise. Okay, so it is a very good application that we can enhance the quality of the image. Now why GANs are developed? Because my basic deep learning and the machine learning model is not able to classify the data when there is a noise available, when there is some fake things are available. Okay. Now components in terms of the visualization. So as I told you, my generator, these are the generator like a thief, and this is my discriminator. It is a police and it is a bank. Now there is a story going on. The story says that my thief, that is nothing but the generator, is going to the bank and deposit some money. Okay, and deposit some money. Have you seen the movie Catch You If You Can? Okay, so in the Catch You If You Can movie, there is a one hero who making the fake notes, right? So same thing is happening over there, but the thing is there is no penalty is imposing over this generator, just a feedback provided by this inspector to this generator that your note is somehow fake over there and you can return the note. So the generator have to go their home and again manipulating their fake images note and again come to the bank, and this process is going to repeated in loop till my bank is not successfully received and accepting the fake notes provided by the generator, and the inspector also can't recognize that which one is the fake and which one is the real, and it is accepted it's fake rupee or a dollar. So this story is running behind my GAN network. Simple story, thief and inspector. But the only difference, there is no penalty over there, just they provide some feedback. But in the real case, there is a penalty. If you are providing the fake notes to the bank, the penalty will be imposed to you. So again, the celebrity generated by, now tell me which one is the fake and which one is the real. First fake. Okay. All are fake. Okay, so we keep it as a homework. Okay, we will share the slide and you can go to home and check. Now you can see this diagram. Generator, there is a noise over there, and from this noise they are generating some images. You can see this is some images initially with having some noise. It is not clear because at the starting level without feedback of the discriminator, generator can't do anything, right? So these are some fake images, or you can say this is unseen data, which is somehow similar to this images that is the real data. So there is a celebrity faces data that is from this is collected. This is labeled as real, this is labeled as fake. Now these two data sets pertaining to the generator and you can say the discriminator, these are going to the discriminator model, real and fake. Now what the discriminator will do? Discriminator will classify that whatever the image you are providing, it is fake or unfake. Okay? If it is categorized as real, then it is called as discriminator loss, otherwise generator loss. So there are two types of losses we have to consider, discriminative loss and the generator loss. In case of discriminative loss, feedback will be given to the discriminator and discriminator has to update it weight value, again train the model and extract the features, right? When there is a generator loss, then generator has to train itself by pre-computation of its weight and the vice versa thing. Now some details. Discriminator is a supervised learning approach. There is a training data available which is labeled also, right? It is trained on real data as well as provide feedback to a generator. So we can say it is a feed forward network. Okay? Feed forward network with back propagation. We can say feed forward network and there is a back propagation. Neural network simple. Generator unsupervised learning approach. It will generate data that is fake data based on the original data. It is also a neural network that has a hidden layer, some activation functions, right? Its aim to generate the fake images based on the feedback provided by the discriminator. Again, it has to train itself. And when the model will succeed, when your discriminator is not able to identify that which one is the fake. Same story. Now some mathematical computation. So mathematical computation says noise is represented as latent random variables. So in the Python, in the mesh processing, there is a one method to generate the noise. So you can use that noise as well. So this noise is represented as a variable Z. This is a generator indicated by G. This is a real world images data set and this is a sample X. Okay, sample I have taken out. Now the generator according to the noise generate the sample Gx. So X is represented as real sample, Gx is represented as sample generated by the generator. Now these two samples are going towards as input to the discriminator. Now according to the discriminator D, there is a loss it will calculate, that is the dx. When it is a real, that is dx, and when there is a fake, that is dgx. So what is D? D is not. D is discriminator. Gx is nothing but the sample. So according to this diagram, there is a one equation. So overall, this diagram is to minimize or maximize this reward function. So sometimes we can say it is a reinforcement learning process. Somehow there is a reward function over there. There is a discriminator loss dx, g is gx, and this one is the Wool formula. So my generator has to minimize this reward and my discriminator has to maximize the reward. Why the generator wants to minimize the reward? Because if the reward given to the model is minimum, more times the generator will train itself and produce and learn to generate the fake images which is pertaining to real. Got it my point? Suppose it is maximized, then if it is maximized, G, if it is maximized, then very less time the generator will twin itself by the new created images, right? Aim will not achieve that the discriminator gets to be fooled. So that's why this reward function is aim, minimize the loss, and D is maximize the loss. This reward, sorry, not loss, this reward. Now EXP data. EX is nothing but the expected value. Log DX. DX is nothing but this one, loss. So cross entropy loss we are calculating. Cross entropy, there is a function of binary cross entropy in the neural network. Same thing we have to implement over there. Plus EZ. So this model is nothing for the generator. This one is for the discriminator. So for the discriminator is a DX. For the generator is nothing but 1 minus this one value DGX. Simple. Okay? But in the program you not need to implement this long formula. Don't worry. There is inbuilt function. So you can just, whenever there is a neural network you are appending, right? In the bracket some parameters you have to pass. So pass the function. The model will do whatever they want to do, but you have to append some learning and the smoothing factor values over there. More clear diagram. Okay? Now sampling, real phase, random noise, again the neural network and generator. Generated phase and this is a real phase. Now the discriminator, under the discriminator it will classify as real or fake. So step by step we are going through programming. Now different type of genetic reversible network. We have to understand about the type, because in the programming we have to select a particular GAN network. So the first one is DC GAN, deep convolution GAN. So in the deep convolution GANs is related to the imagery itself because there is a term convolution, right? And your DC GAN is pre-trained with a some data set that is called ConsNat. So now ConsNat is some image data set. Second one is conditional GAN and unconditional GAN. So conditional GAN means there is some condition associated at the discriminator. At the discriminator side, before going to categorize the data as real and fake, it has to append some conditions. And unconditional one is nothing but this one, least square. In the machine learning, there is a term mean square error, MSC, right? In the machine learning, there is a term mean square error, MSC, right or wrong? So what is mean square error? Whatever the error is, we have to square root. Square. Right? So least square, the thing is same as mean square error, but we have to take in the least value. Auxiliary classifier GANs. In this auxiliary classifier GANs, before going to the real and fake, along with the real categorization, it has to provide the attributes, that based on which attributes they are make a decision that it is a real, or based on which attributes they are making a decision that it is a fake. So it is a very simple to understand for the generator that we have to concentrate over this attribute. Okay? We sometimes telling to the student that you are very good in the coding, but your theory part is somehow weak. So we are trying to improve the performance of the student, but providing some attribute value also. Same thing. Then dual video discriminator. Dual video. There is a video. Then what is the meaning of dual? There is some dual audio term, right? So dual video discriminator means when there is a video, right? And there is some another features associated with another video. we are appending two videos at a one frame. ठीक है, deep fake very hard to implement because we are integrating two videos. Like you can say in the old movies, there's Govinda movie, so many, in which there's a double role, right? So what they are doing, in a one frame, Govinda is standing over and talking to someone, and the another one is talking to someone and just framing to each other in the one frame. And in the visualization, it will act as a one frame that Govinda is talking to another Govinda. Understood? Now SR gain is nothing but my resolution focus. As a last application is low resolution to high resolution. So they are going to train a pre-trained model with a resolution images. Now cycle gain. Cycle gain is nothing but the transformation. Transformation means in the image we have to replace the image, or you can say the face of something else. Transformation. Info gain. Info gain is completely the unsupervised, in which both the discriminator and the generator are based on unsupervised model. Now you can say how can we train then? There is a need of training data for the discriminator. So first the discriminator will going to implement by using the unsupervised learning, reinforcement learning. When there is some situation is under control, then the generator will comes into account. Again, same game. Which one is the real and which one is the fake? So why I am taking these images? Because my topic is GAN theory as well as implementation of GAN by using the MNIST data set. So this is MNIST data set over there. Okay. So in the end of the session, we are going to create these images like, and your discriminator will not able to detect the fake images. That is our hands-on session. Now tell me, which one is the real and which one is the fake? No, you can classify, sir. अगर आपने वीडियो देखा हो न्यूज, जो रश्मिका एंड आलिया कंट्रोवर्सी है, so there are some methods we are giving to the scientists, or we can say some users, such that they can identify that which one is the fake and which one is the real. Like if you are seeing some fake video, you can focus over the eyes are not moving properly, and the image expressions are not up to the level as the real one. So we have to focus more over the images and the videos things, such that we can identify. Like in the previous one, you can say in the generated images there is some noises. You can see. So in our hands-on session, we will take this MNS data set, that is real world image data set. Some vector I have to create with a normal distribution noise. Generator I have to train. Then from the generator, I have to create sample images. These are nothing but the fake images. Now my discriminator will going to train with the real images first, then the sample images second. Now at the initial, my discriminator will to identify which one is the real, which one is the fake correctly, right? And after that, we have to combine train and testing and provide the feedback to the generator, such that my discriminator will not able to identify that which one is the fake and which one is the real. So that architecture we are going to implement. So what are the steps? First, we have to define a problem. Okay. So problem, which type of problem we are dealing with? Image. Second, select architecture of GAN. So it is a style GAN, or it is a, you can say what is DC GAN. So it is a DC GAN. DC GAN it is. Okay. There are some pre-trained images, means data set is available, and it is an image data set. Train discriminator on real data set. In this, we have to first provide the forward part. There is no back propagation at the initial. Only contains real images and samples generated by the generator, as I told you. Third step is classify both real and fake data. We have to check that my discriminator is working properly or not. Haji? Discriminator loss. There is some cross entropy loss that is called the discriminator loss, will help us to improve the performance. Now weights of the discriminators are updated when somehow my discriminator is not able to identify that which one is the real and which one is the fake. At the initial when there is a no back propagation. First we have to prepare our discriminator. Cryptography subject you know, cryptography and network security, right? So in the cryptography network security, this is a third year or a fourth year subject and sometimes electives in the higher semesters, you can say MTech and PhD, right? So cryptography, we have to first deal with the cryptographic algorithms. We have to learn the algorithm. And after each algorithm learning, we have to perform the cryptanalysis. Attacks over there. Okay? So first we have to learn the algorithm, then we have to do the cryptanalysis. Same thing is going on. First we have to learn. Discriminator is learning, generator is learning. Then we have to perform the attack by taking the feedback. Now train generator. Fake inputs of the generator by noise. Generate some fake outputs. Tries to transform it into meaningful data. As I told you in the first one, we are providing only the noise because this is based on the approach of unsupervised learning. We are just provide the correlation between this one and this one image, and it will take lot of epochs to provide the similarity between these two images because there is no labeled over there. So 12,000 or 15,000, sometimes 20,000 epochs you have to iterate your generative model to learn something from the discriminator. Now calculator the discriminator loss, perform the back propagation through the discriminator, and again update the weight. Train discriminator on the fake data, whatever the samples from the generator you have, you just going towards the discriminator and train it. Now step, we are proceeding to the hands-on session. What is the time we have? Yeah, enough time. Importing all the libraries, getting data set, then data preparation, like we have 3-dimension images, color format, we have to create it in 2D. You know, na? Deep neural networks do not work in the 3D dimension. Okay? Or from the 2D, you have to convert it into 1D. Grayscale image. Define the function generator and the discriminator. First, we have to define the function only, not the model. Function. Create a random noise and create an image with the random noise. Setting parameters like defining epoch, batch sizes, and normalization. Define the generator of generating sample images. So there is a model and there is a sample image generated by the generator. Now train the discriminator from the fake images as well as the real images and create the loss. We'll see what clarity of images is created by the generator at the last. As you can you can't distinguish over this one, right? Gaya. नहीं 1 second हो जाए. We can't distinguish, right? So like this way we have to create by our hands-on session. So I mean this data set, it is created by someone that we are importing only. So it having a handwritten digits from 0 to 9. Okay? And there are about the size of 28 cross 28, and there are total 60,000 images. Okay, so our aim is to train the discriminator model with this minus data set with some noise, and after providing some sample noise as minus to generate the model to generate the same information from the generative irreversible network. So let's go to the hands-on session. Jupyter notebook install hai in your desktop file. अरे क्या हुआ? It is visible. Yes. So NumPy library, you know about it. Yes? Pandas, Matplotlib, OS, TensorFlow to work with the neural network. Then Keras. Inside the Keras, we have import something input for the inputting layer. Dense, because we are providing the deep neural network, we have to provide the hidden layers also. So dense neural network we are going to create. Leaky ReLU. What is leaky ReLU? It is activation function. Activation function. Dropout. So leaky ReLU is your activation function. The aim of the leaky ReLU to provide the feedback. Okay? Feedback to the generator. So ReLU only gives from 0 to maximum, either 0 or maximum. But the leaky ReLU is not about the 0 to maximum. It provides some sort of value to the generator such that generator can train itself at each iteration. Okay? That's why we are focusing over the leaky ReLU in spite of ReLU. Now dropout. What is dropout? Inside the neural network, we have provided some dropout. This dropout, we have a probability like 0.5. Okay? Suppose we have 5 inputs, and my dropout is 5, 0.5. So how many inputs we have? 5. ठीक है? 5 का 0.5 कितना हुआ? 0.5%. 5 का 0.5. हाँ, 5 का 0.5 कितना हुआ भाई? ओहो, हाँ, 2.5. So we are taking this upper value 2. ठीक है? And with this upper value, we are dropping 2 layers. Suppose 1 and 3. So why we are doing? We have to focus more on the features, more on the attributes. Suppose we have so many attributes like images. There are so many attributes like there are so many pixels we have. According to that, there are so many colors we have, so many shapes we have, edges we have. Right? So at each hidden and each iteration, we have to provide some dropout value that each time some of the input will get suspended and rest of will perform the weighting computation. Like weighting W1 X1 plus bias. यही होता है. यही होता है W1 into x1 plus y's value. So if my W1 and x1 plus y's value, this is a summation. ठीक, this x1 is nothing but your features. ठीक है, if this value is less, then we can focusing more on some few features that which are cooperating. Otherwise, the value get large, right? ठीक है, so dropout is basically increase to understanding about the features. Extracting features की जो properties है वो उसको higher करता है. Then batch, this one, how to decide? We are just providing the input now. Input here, random. It is selected by random. Randomly. Each iteration it is randomly. No, automatically. Just you have to mention this parameter like 0.2, 0.1. Then batch normalization. So batch normalization provides the stability. Stabilize the neural network. How? Same example. Like we are running a college, right? There are suppose 400 intakes. If I am taking the class of 400 in a combined way, that will be fruitful. Or if itself I am dividing the whole 400 into 4 batches. Simple. That's why the batch normalization is doing. We are just providing the batches, input batches like 32, 32, 64, 100, like so many like batches. And for these batches, we have to provide the training to our model. And for each batch, we have to ensure that your mean and variance should be put at some value, some idealistic value that is decided by you or either by the model default value. Okay, such that normalization will be taken out. Okay, like if we are running out 4 batches, 100, 100, 100, 100. Okay, at the last we are doing the grading, then cutoff will be same for all, right? Cutoff same रखते हैं ना? If you are doing teaching the same subject, C programming, C programming, C programming, but the cutoff is same, as well as syllabus is same. So we have to mention some parameters that should be ideal. If you want, you can type this in your Jupyter notebook. I can provide you some more material like this one in PPT also. If you want to type and just perform it, you can perform. It's your choice. Yeah, sure. You can use Google Colab. Now model I have to import. Inside the model, we have to pass the parameters and optimizers like Adam optimizer providing the learning rate and the smoothing factors. Okay. Now second one, minutes. So this one is the object, right? This one is the library. TF is nothing but the TensorFlow. So TF under Keras, and inside the Keras we have a data set, and my data set name is minutes. From this minutes I make an object. So each time when you are fetching the features of the data set, you have to give the name minutes inside the whole code. Now training and testing division. So load it, and from this loading, X train, Y train, X test, Y test will be automatically provided to you. Why? Because the user of the minutes data set have already labeled your data with X train and Y train for your suitability. Otherwise, in the basic data set, you have to provide X train and Y train separately. कि कितना आपका 0.8%, 80% आपका ट्रेनिंग होगा या टेस्टिंग होगा, तो आपको करना पड़ता है, पर यहाँ पे ऑलरेडी है. Now scaling the inputs. Scaling the inputs in the range of -1 to 1 for better training. Why minus 1 to 1? Why minus 1 to 1? It's a simple normalization. Huh? 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 Because the pixels is from 0 to 255. So there are so many variations, right? 0, 1, 2, 64, 100. Yeah, so it is a simple normalization from minus 1 to 1. Okay. Now once you compile it, it will load the data. Okay. Then for loop, this one is optional. Just I want to see that what are the plots I have having inside my minus data set. So just I'm appending for loop 7 cross 7, 7 images and 7 rows. 7 rows and 7 columns over there. And some training data I have to plot. So these are the real data. Okay. Now what are the second step? Pre-processing. Pre-processing. So inside my pre-processing, I have to change the dimension. You can see. So and HW, extent, shape, number, height, and width. We have dimension of 28 cross 28. So we have to perform 2D to 1D, right? 2D to 1D. So we have multiply 28 and 28 and there is a dimension D and now xtrain and xtext will get reshaped with a computed dimension D. Simple. So 2D to 1D create हो गया. Now the generator model. Okay, we are not compiling, generating the model only. These are the functions. So inside this is a latent dimension. This is nothing but the noise. Okay, this noise I have to put inside my image. So this is the second line. There is a function build generator, and inside the generator we have to pass this noise 100. It is decided by me itself. You can change it. Noise is a random noise. You can change it. Range you can, but if you select the more noise, na, your model has to train more. So it is average value. Hmm. In fact, in the 100 one, I have to train my model 1200 epoch. Because generator is unsupervised, right? So that's why. So I, that is our input. You are asking, na, what is the input? That is the input model. Under this, the shape is I have to provide the 100 noise only. Noise I have to pass inside my input. Now this is a dense neural network over first layer. Inside this activation function is leaky ReLU and alpha is 0.2. So your alpha is 0.2 is what? As I told you, we have to take not a 0 to maximum. We have to take not 0 but something value, something to maximum. So there can be two possibilities, negative loss and positive loss. So when there is a positive, then it is okay. If it is a negative, then it will be multiplied by this value 0.2 and again some computation have to perform and convert it into the positive value. So we can stick over the positive ones only. Okay. Now batch normalization, momentum is 0.7. Okay, what is momentum over there? Batch normalization. Anybody can tell what is momentum? Actually, this momentum value is decided by my input set, because my input is 100 over there. Noise is somehow bigger. So we have to provide the good range of momentum. Basically, the momentum value is lies between 0 to 1. So if you have a less noise, then 0 to 0.5, otherwise 0.6 to 0.9. बताया तो बैच नॉर्मलाइजेशन के लिए नहीं, अब होगा बैच नॉर्मलाइजेशन. If your input, as I told you, if I input your higher side, then we have to select 0.6 to 0.9 randomly. So in case I am selecting 0.7. Okay. Hmm. Hmm. Okay. Sampling length. Images हमारे पास 60,000. ठीक है. So if you provide 0.9, batch कितने का होगा? Momentum is again decided the batch size. हाँ, that's why. So less value, so less momentum, high value then high momentum. हाँ जी. हाँ. Then dense, hidden layer. Where is the pointer? Oh, sorry. Dense 512, dense 1024. Then it is a momentum again dense. Now this is the last one. Output layer. Output layer. ठीक है. So how many hidden layers we have? One. हाँ. How many there? Three. One, two, and three. Under these three hidden layers, we have batch normalization and activation is leaky release. Then the fourth layer is nothing but output layer, in which my activation is 10H. So why we are providing 10H? Because my pixel is -1 to 1. 10H का मोर फोकस होता है कि वो मुझे आउटपुट देगा -1 से 1 के बीच में. So that's why we are choosing -1 to 1 10H. If you are choosing -1 normalization, तुम कैसे भी कर सकते हैं, 0 से 1 के बीच में कर सकते हैं. उस केस में कौन आएगा? हाँ, 0 to 1 पॉजिटिव है. एक्टिवेशन फंक्शन है एट द लास्ट. कॉसेक्स ले सकते हैं. और उस केस में क्या लेंगे? सिग्मॉइड तो नहीं ले सकते, राइट? सिग्मॉइड इज फॉर द क्लासिफिकेशन. क्लासिफिकेशन के लिए ना, लेबलिंग के लिए, या फिर 0 या फिर 1. हाँ, वो ले सकते हैं. ठीक है. So you have to check that according to your output suitability, which one activation is choosing by you. Basically, it is a hit and try, but it is not completely blindly hit and try. According to your value, you have to decide. Like my value is -1 to 1, so we have to decide at 10H. Then model, again, object is made, and under the model function, we have pass I, that is input, and your parameters, that is X, and return model. Now discriminator. How can we build a discriminator? Image size. What is image size? Image size हम आगे पास करेंगे. It is a function only. It is a function only, right? So image size I have to pass. Then how many layers? 1. Input layer. 2, 3, 4. Hidden layer कितनी है? 2. Output layer 1, one is input layer. ठीक है? Should I need to tell this one? And here we have used sigmoid. Why? Because we are dealing with classification. Which one is the real and which one is the fake? So either 0, either 1. 0 is real, 1 is fake. Functions are completed. Now build and compile. So for building, build discriminator and the value of D. What is D? D is nothing but my image size, right? You can see, right? Image size. So what is D I am passing over? That will be act as image size. And what is D? Capital D. D is nothing but dimension. We have multiplied earlier, right? So we are passing dimension under this function, image size. Understood? Now discriminator dot compile, binary cross entropy. You can see cross entropy is nothing but my reward function. Reward function that I told you, VGD. So that is binary cross entropy. Optimizer is Adam. This is the learning rate and this is the dropout. Okay. Now matrix, I am only focusing about the accuracy. Now build and compile the combined model. So combined model means first we have to create the generator, then we have to create the discriminator, then combined. Feedback is going. That is the correlation. Back propagation. Yes. Huh. No, it's okay. Now build generator latent dimension. You can see what is the latent dimension 100 noise. So generator मेरा बन जाएगा. Then create an input to represent noise sample from the latent space. So Z is nothing but my input shape latent dimension, that is my noise. As I told you in the diagram, there is one variable represented the noise that is called Z, if you remember. So the same thing is Z over there. Pass noise through a generator to get an image. So you have to pass this noise generator and in the parameters pass this noise. That was a function. Now we are going to generate the sample. Here we are passing. Here the previous we are defining the dimension. Okay? But in the function we are passing the dimension as a image size. Discriminator. Now when the generator is made, your discriminator will go ideal because we are not combining train. अभी हम sample images create कर रहे हैं. So discriminator should be in the ideal state. So discriminator dot trainable equal to false. Now discriminator image equal to fake prediction. What is that? Whatever the image is generated by the generator, that is a noisy image, that is passed through the discriminator because discriminator has to again train with images for the first time. So the same thing I am doing. This noisy image to the discriminator, and that is nothing but I am saying the variable fake prediction. अभी तक clear है story? Now the generator function is completed. Now we are going to generate model. So the model is saying combined model generator equal to model itself. Z is my noise and the fake prediction, that is that one. So that is fake prediction means cross entropy value. What the discriminator will do, if you pass the image to the discriminator, it will provide you the loss in terms of predicting the label 0 and 1. Providing the fake images, then there is some loss. Generator is trained. That loss is captured by fake prediction variable. That loss is captured by this fake prediction model. And again, I am passing this fake prediction to my combined model generation. Why? Why? Because we have to generate the sample images pertaining to training images. Pertaining to training images. Because we are working over the unsupervised. ठीक है? अनसुपरवाइज में जनरेटर को कुछ पता ही नहीं है कि वो हाथी है या घोड़ा है, ठीक है, डिजिट है या कार है. So by using this fake prediction value, generator will able to specify that okay, somehow I have to create this one sample images. Somehow I have to create like this one sample images. So that's why this combined model I have to pass the noise as well as the fake prediction. Now compile the model. Dot compile is a method, just dot operator. Loss, binary cross entropy and optimizer Adam. फिर से क्यों? फिर से binary cross entropy क्यों? We are creating the generator model itself because we are talking about the combined model. अब तो मेरा combined हो गया ना? Like the generator is generating images and fed it as an input to the discriminator. Discriminator will provide the loss and the feedback. So sigmoid will use where? Reward function, sir. Reward function. हाँ हाँ, जो एक mathematical equations I illustrated you ना. So that is depend upon the cross entropy method. Here we are using binary cross entropy. Yeah. Now this one is the batch size 32 and with a momentum of 0.7. ठीक है. Epoch 1200. पहले मैंने 12,000 के लिए किया था, but after that 1200. Then sample period is 200. Why is the need of sample period? Because when the noise is generated, when the loss is generated by my discriminator, again the generator has to predict the weight, compute its model, train the model and generate again sample images. Okay, so after 200 seconds the sampling will be done. Huh. Now ones and zeros. What is the ones represent? Okay, मैंने उल्टा बोल दिया है. Ones का मतलब है real and zeros का मतलब है fake. ठीक है, वाइस वर्सा मैंने बोल दिया था इसके पहले. स्टोर जनरेटर एंड डिस्क्रिमिनेटर लॉस टू प्लॉट द ग्राफ. ग्राफ प्लॉट करना होगा तो आपको ये एरेज की जरूरत पड़ेगी, दैट इज डी लॉसेस एंड जी लॉसेस. ठीक है, इफ यू आर राइटिंग अ पेपर देन इन द टैबलो फॉर्मेट इट विल आल्सो नीड टू फेच डी लॉसेस एंड जी लॉसेस. रिसर्च पेपर में हम टेबल दिखाते हैं ना, वहां से आप एक्सट्रैक्ट कर सकते हैं डायरेक्टली. नाउ this is the optional one for the visualization. Like whatever the sample is created by the generator, you can see under the directory GAN images. It is optional. Now function to create sample images. As I told you, sampling will be done after 200. Then what is the sample images? Sample images is 5 cross 5 rows and columns. The noise is MP random and random rows and columns and latent dimension. Means 5 cross 5 का मुझे फ्रेम का एक चाहिए क्या? Latent dimension means noise. मैं क्रिएट करूंगी एंड इमेजेस जनरेट करूंगी. रख सकते हैं, पर 7 क्रॉस 7 से कम होना चाहिए. हाँ, उससे छोटा हो सकता है. मे बी मिली सेकेंड में होगा सर, मिली सेकेंड में होगा. Then generator predict noise and images, rescale the images. Again we are doing the same process. ठीक है, from -1 to 1 doing the sample images, same thing, but for the batches we are doing. So this graph is not visible. Why? Yeah, it is visible. Now training and testing we will start. Training, it says for the epochs, how many epochs we have? 1200. अब 12,000 भी ले सकते हैं. More epochs you will take, more training time you will need, but more accurately classify your discriminator. So select a random batches of images with a momentum of 0.7 IDX, NP random, rand int 0, train shape and batch sizes. ID मैंने लगाई है सबकी, हर एक इमेज की ID, ठीक है, such that we can classify ना. लास्ट में मेरे को कंपेयर करना है ना, तो मुझे आईडी देनी पड़ेगी, राइट, वही आईडी दी है. देन एक्सटेंड दिस IDX and real images विदाउट नॉइज इमेज है ये. देन जनरेट फेक इमेजेस. कैसे करेंगे फेक इमेज जनरेट? पता है, नॉइज एंड फेक प्रेडिक्शन, सैंपल इमेजेस क्रिएट हो जाएंगी. देन डी लॉस रियल एंड डी लॉस डी एक्यूरेट रियल. डिस्क्रिमिनेटर ट्रेन ऑन बेस रियल इमेजेस एंड वन. तो रियल इमेजेस का मेरा पैरामीटर है 1 and the second one you can say fake images का 0. Discriminator dot train on batch, discriminator dot train on batches. Now the loss will be computed. Real plus d loss, real plus d fake, 0.5 with a multiplication. So this is how my discriminator will train, and this is how my generator will train. You can see the code. If you have any doubt, you can ask. Rest of the functions are explained by me, like combined model generation, right? Just see the code. Where? This one? इसके पहले किसी को डाउट है? हाँ, ये लॉस ऐड है. क्यों ऐड किया है? कंबाइंड लॉस होगा ना सर, दैट्स व्हाई. हाँ, अब यहाँ पे बोल रहा है इफ इपॉक इज डिवाइडेड बाय, कंप्लीटली डिवाइडेड बाय 100, ठीक है, देन वी हैव टू प्रिंट दिस वन. तो लाइक ऐसे कुछ आएगा आपका, इस तरीके से, टाइम वगैरह, वो उसी को प्रिंट करने के लिए कोड है. एंड इफ इपॉक इज परफेक्टली डिवाइडेड बाय सैंपल पीरियड मींस 200, ठीक है, तो सैंपल इमेजेस के अंदर मैं अपना इपॉक पास कर दूंगी. मींस इफ वी हैव 1200 इपॉक, then 1200 sample images I have to create. ठीक है, वही है. Now I am read for image reading. Now one directly made by me optionally, that is GAN images. So GAN images is nothing but whatever the sample I have to create, है ना, whatever the sample I have to create by appending the noise and from taking the help as a loss from the discriminator. So these are the GAN images folder. Under this I have used 0.png at the initial level. 0.png means when we have to train our generator with two things. First one is the noise, second one is the loss taken by the discriminator. First time. So you can see the beauty of this model. At the first time, by using the loss, it can quickly recognize that okay, this one is the handwritten images. Pixel correlation is done by them very quickly. Why? You can hit and try with various parameters over there. Like first one is the epoch. पहले मैंने बताया था कि epochs मेरे 12,000 थे, फिर मैंने 1200 किए, मतलब टोटल कितनी बार मैंने epochs चलाए? 12,000 plus 1200 is the total time. So my epochs were higher. First thing. Second one is my optimizers are also very ideal. Like my momentum is high, perfect value. My learning rate is good. Okay. My dropout material is also good. So you have to deal with this material to create this type of images. Okay. So if you are learning from the scratch, it might be possible for the first time you will not get this type of image. You will get only this one circle and dot 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 dot. Like first time I am getting. When we are analyzing more parameters, that okay, when my dropout is 0.5 instead of 0.2, or my learning rate should be 0.004 instead of 0.001, then we can say this images. So as you know, in the deep learning, nothing is fixed, right? Like whatever the code we are capturing from somewhere, we are just manipulating the code by changing the parameter for the first time in order to learning the process to create the research paper, right? So no, we are doing all the same things inside the deep learning. Once we are comfortable, then we are doing the from the scratch. So the code is with you, you can play with it. But there is some noises over. You can see this one is not recognizable. This one is also not. This one is also not. This one is what it is, I don't know. So there are so many. This one is also somehow. This one and this one is similar. So it is pertaining to learning, but is not the ideal one. Anyone can say this is generated by the deepfake, right? But when my training is going on and I am taking the 800 sample image, 800.png you can see. So you can see here are somehow shape is going on. Okay, like it is 8, it is 6, it is something like 2, it is 3, it is 6, it is 0, it is something I don't know. As a turning training proceeds, it will going to more learn and provide the good images to you. Now there is one homework with you. Okay, homework is what? Homework is first you have to run the code 12,000 epochs. Okay, once you done, you have to pick one image from the this generative model, either this one or this one. It's up to your choice. And pick one image from the real training data, the same bunch. Like 5 cross 5 में वहाँ पे भी आप 5 cross 5 ही उठाना. सैम्पल इमेजेस 5 cross 5 थे ना मेरे, तो वहाँ पे भी आप 5 cross 5 ही उठाना. Then we have to compare according to parameters like accuracy and plot a graph. You have accuracy, you have to plot by using the matplotlib, as well as you have to stick to a particular image like img and image parameter as 1 from the generative and image parameter as 2 from the discriminative, and analysis that which one is the real and which one is the fake. This is small amount of homework you have to do. Okay, or else there's a homework number 2 for the more clarity. Homework number 2 is you can download the celebrity data set. Okay, celebrity data set and train the discriminator by the celebrity data set. Now train the generator by the noise along with your face created data set. Just pick your camera, capture your face, crop it, reduce the dimension by 7 cross 7, put noise over there and feed over the generative model, your face. And at the last, you will able to check that your face that how many iterations it will going to change to the Alia Bhatt face. You can, and the males also Ranveer Kapoor. Okay, so for the females, the target is Alia Bhatt, and for the males, the target is Ranveer Kapoor, or according to the choice, you can take any actor or actress. Interesting homework, you can see. Any doubts, you can ask. The PPTs and all the code will be provided to you. And in the PPT in the last, there is a Google Colab link also. So there is no need to write all the code because it is a PDF, right? So Colab link is also given in the PPT. You can directly go to the link. There is one request that will be have to ask by you to me that I will access to you, and then you can fetch the details. So what we learned today? GAN and also some dangerous things. Dangerous things. Now, what is the major application areas going on? अभी तो मैंने सब dangerous बताया. What is the helpful one? Helpful one says for the females it is very good. Like so many filters inside my phone, right? Also, Microsoft is collaborated with OpenAI. Okay? So there is one advertisement is going on. Advertisement is there is a one man standing in behind of the aside of the ocean and just throw their child to the air, right? Capture the pic and just slide the child over somehow meter away, and it will act like a very real image. So this is nothing but again the deep fake. Animated movies, another example. Like some of the movies I have saw the scene and just I can't imagine that okay my India is also very good in looking. Yes, animated images or you can say the games. So there are so many good applications also, but every technology has some drawbacks as well as some advantages. So stick over the advantages only and try to learn the things and explore the things and write the research papers more and more. Yes, any doubts, ladies? Yes. Okay, sure, sure, sure. Can you give your introduction such that I can recognize you? Fracture detection. Okay. Mm-hmm. Medical image analysis. हाँ. लो टू हाई रिजोल्यूशन में हेल्प करेगा फिर आपको क्योंकि एक्सरे के इमेजेस आप देखेंगे तो दे आर सो मेनी नॉइज ओवर देयर तो सिटी स्कैन में भी बहुत नॉइज होता है सर इफ यू आर टॉकिंग अबाउट द अल्ट्रासाउंड आप लोग बैठ जाइए ओके प्रियदर्शनी ओके प्रियदर्शनी से भगवती भगवती मतलब अच्छा 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 ओके आप सेम कॉलेज ओके ओके संविधान प्रियदर्शनी कॉलेज मेन पीसी ओके विच डिपार्टमेंट सर बायोटेक्नोलॉजी ओके हाँ हाँ आपसे तो मुलाकात हुई सुबह ये कहाँ है ओ अमरा से आए हैं आप ओके ठीक यस सर एनीथिंग एल्स Welcome, sir. What is that article discussion? Hmm. Okay. Yeah, sure. Where from? From where, sir? Okay. So you are pursuing. Okay. So it was part time. Hybrid means. Okay. Which college? Once again? No, no, no. From post doc. Mm-hmm. 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 Okay, sir. We have. Yes, we have. Actually, we are currently working in sleep disorder problem identification. Like just from the sleep disorder, what are the mental distortions we have faced? So we have some like Z data and D data in terms of signals. So somehow EC and somehow some computer science things we are doing over there. Yeah, sure. Mm-hmm. Sure, sir. Sure, sir. ठीक है हाँ नहीं नहीं